Welcome back to The Deep Dive, where we will dive deep into the fascinating stuff you've been digging into.
Right.
You sent over some really interesting material on Spark streaming architecture. Looks like you're aiming to really get how this whole system ticks,
Yeah.
especially the microbatch processing and how it handles potential hiccups. We've got the perfect person to break it all down,
Okay.
our expert speaker.
Spark streaming is a fascinating beast.
I know, right?
And the way these sources use a WWE analogy to explain it,
Yeah.
well, it's surprisingly insightful.
Microbatches and wrestlers who knew.
It's a,
Okay, so before we get into the Royal Rumble of it all,
yeah,
can you set the stage?
sure.
What exactly is this microbatch concept?
Imagine trying to analyze a torrent of data coming at you nonstop. It's like trying to drink from a fire hose.
Right.
You can't process every single drop the instant it hits you.
Yeah.
You need a way to manage that flow to make it digestible.
Okay.
That's where microbatching comes in. Instead of tackling each data point individually,
Yeah.
Spark Streaming bundles the data into small, time-bound chunks,
Okay.
these microbatches, and then processes them as a unit.
So it's like taking strategic sips from the fire hose instead of getting completely overwhelmed.
Exactly.
But how micro are we talking? Like, how often are these batches formed?
We're talking seconds here,
Okay.
often as short as 1 to 5 seconds. This sweet spot strikes a balance between processing a large volume of data quickly,
Okay.
high throughput, while keeping the lag time,
Mm-hmm.
what we call latency, to a minimum.
Latency being that delay between the data arriving and us actually making sense of it.
Exactly.
Okay.
And minimizing that delay is super important for any system claiming to be real-time.
Now, this is where the sources get really interesting.
Uh-huh.
They bring in this whole WWE Royal Rumble analogy to explain how these microbatches work.
Yeah, this analogy, while unexpected, is actually quite clever.
So walk me through this.
All right.
How does a wrestling match translate into data processing?
Picture this. The wrestlers entering the Royal Rumble at fixed intervals.
Okay,
Those are your data points streaming into the system.
I see.
Each time interval marks the formation of a new microbatch.
Okay.
And once those wrestlers are in the ring, they all battle it out simultaneously.
Right.
That's your processing happening within each batch.
So it's like organized chaos within a defined time frame.
Right.
You have this constant influx of wrestlers mirroring the data.
Yeah.
But the actual processing, the wrestling, occurs in these distinct time-bound chunks.
Precisely.
Yeah.
The Royal Rumble analogy really captures that balance between managing a continuous flow of data and processing it in a controlled manner.
It's brilliant.
It is.
Okay, so we've got this microbatch architecture, but to really appreciate it, I think it's helpful to compare it to the traditional batch processing approach,
Right.
which is a different beast altogether.
It is.
Could you walk us through the key distinctions?
Absolutely. Think of a mountain of data that needs processing. In the batch world, you'd grab the entire mountain,
Right.
process it all in one go,
Right.
and then maybe schedule that job to run periodically. It's like a meticulously planned and produced WWE pay-per-view event.
Okay.
A complete package delivered at a specific time.
Okay, a pre-recorded spectacle.
Yeah.
Everything neatly packaged.
Right.
But with streaming, it's more improvisational.
Exactly. Streaming is like WWE Monday Night Raw going out live.
Okay.
As the data comes in, it's dealt with immediately.
Right.
It's about real-time reactions and insights,
Yeah.
adapting to whatever comes your way.
So batch processing is all about handling volume in these scheduled bursts, while streaming is about continuous processing for immediate results.
Yes,
Each approach has its own strengths, I guess, depending on what you're trying to do with the data.
you got it.
Now let's move on to another fascinating piece of the Spark streaming puzzle.
Okay.
D-streams, or discretized streams. What exactly are these, and why should our listener care?
Think of a D-stream like a wrestler's career.
Okay.
It's a continuous timeline, right?
Right.
But it's actually made up of many individual matches.
Okay.
Those matches are like RDDs, resilient distributed data sets, which hold the data from specific time intervals. So a D-stream is essentially a sequence of RDDs,
Okay.
much like a wrestler's career is a sequence of matches.
So it's like each RDD is a chapter in the wrestler's story.
Yeah,
And the D-stream is their entire career arc.
that's a great way to put it.
Okay.
And just like you can track a wrestler's evolution and changes over their career, you can apply transformations and actions to D-streams to process and analyze the data as it flows through the system.
This WWE analogy is really bringing these concepts to life.
It is.
So as the data streams in and gets divided into these RDDs, What happens next?
Wow.
How does it actually get processed?
That's where the driver program comes in.
Okay.
Our Vince McMahon of the Spark streaming world. It's the central control center.
Okay.
The mastermind calling the shots.
Hi.
It creates the streaming context, defines how the data will be processed,
Okay.
and then manages the execution across the cluster.
So sticking with the analogy, the driver program is deciding which matches happen, which wrestlers are facing off, and how the whole storyline of data processing unfolds.
Precisely.
Okay.
The driver decides how the data gets divided into those micro batches we talked about,
Yeah.
and then schedules those batches as Spark jobs. It's the ultimate coordinator making sure everything runs smoothly.
Okay, so we've got our mastermind driver program.
Right.
But who's actually doing the heavy lifting, the actual processing of the data?
Well,
That's where workers and executors enter the ring, right?
think of workers as the arenas where those WWE events are happening.
Okay.
These are the nodes in your cluster that host the executors and the executors.
Yeah.
They're the wrestlers themselves, the ones performing the matches.
Okay.
They're JVM processes running on the workers, and each executor can handle multiple tasks simultaneously.
So multiple executors on a single worker means multiple matches happening at the same arena, right?
Yes.
Like having several rings or segments going on at once.
Exactly. And just like WWE might have multiple rings or segments running simultaneously, your Spark streaming application can process different parts of your data in parallel using multiple executors.
It's like a well-choreographed dance of data processing.
Yeah.
With the driver calling the shots and the executors executing the moves.
It is.
But what happens when things go wrong? A wrestler gets injured? A microphone malfunctions?
Right.
How does Spark streaming deal with these unexpected hiccups?
That's where fault tolerance comes in.
Okay.
Ensuring that even when things go off script, the show goes on.
Okay, tell me more about that.
Right.
What safeguards are in place to make sure data isn't lost if something goes wrong?
Well, Spark streaming has a few tricks up its sleeve. There are three main mechanisms that work together to ensure fault tolerance: RDD lineage checkpointing and write-ahead logs.
Okay.
Let's start with RDD lineage.
Right.
Think of it as a wrestler's training regimen.
Okay.
If a wrestler suffers a setback, they can rely on their training to get back on track. Similarly, every RDD remembers how it was created,
Yeah.
what transformations were applied to it.
Nice.
So if an RDD is lost due to a failure, Spark can reconstruct it by replaying those transformations.
So it's like each RDD has a built-in backup plan based on its history, its lineage.
Yes.
Pretty clever.
It is.
Now, checkpointing is more like a wrestler's ultimate safety net.
Right.
Okay, I'm intrigued. Go on.
Imagine a wrestler suffers a major injury and needs time to recover. They have a plan in place to ensure they can return to the ring when they're ready.
Right.
That's what checkpointing does for a Spark streaming application.
Okay.
It periodically saves the application's state to a reliable storage system. So even if the driver program crashes, the entire operation can be recovered without losing all the progress.
That's a relief. So it's like having a safety net for the entire application, not just individual RDDs.
Exactly. Then there are write-ahead logs. Think of it like WWE filming backup angles during a live event.
Oh, I love that.
Yeah.
Explain how that applies to Spark streaming.
Before Spark streaming processes any data, it first records that data in a log.
Okay.
This means that even if a failure occurs during the processing itself, no data is lost.
I see.
Spark can simply replay those logs and ensure everything is accounted for.
It's like having a safety net for the data itself, making sure it's protected, even if things go haywire during processing.
Precisely. These fault tolerance mechanisms ensure your Spark streaming application can handle the unexpected and keep chugging along.
Yeah.
Just like the WWE always manages to put on a show no matter what challenges pop up. It really is impressive how those mechanisms work together to create this intricate yet robust system.
It is. So we've walked through this whole micro-batch architecture, how it differs from the traditional batch approach, the idea of D-streams as these timelines of data, the driver program acting as our Vince McMahon, the workers and executors doing the heavy lifting and all those safety measures, ensuring nothing gets lost when things go wrong.
Yeah.
But let's zoom out a bit.
Yeah.
What are some real-world scenarios where this Spark streaming magic actually comes into play?
Well, think about any situation where you need to analyze data and react to it in real time.
Okay.
You brought up WWE, and it's a surprisingly good example. Imagine tracking social media sentiment during a live event.
Okay.
Spark streaming could be analyzing tweets and posts as they come in,
Yeah.
giving producers insights into how the audience is reacting to different wrestlers' matches or storylines. They could even adjust the show on the fly based on that feedback.
That's incredible. So it's like having a finger on the pulse of the audience's emotions in real time.
Yeah.
What other applications can you think of?
Oh, there are tons. Take fraud detection in financial transactions. Spark streaming can analyze incoming transactions for suspicious patterns,
Right.
flagging potential fraud attempts as they occur. This allows financial institutions to respond quickly, potentially preventing significant losses.
That makes sense. It's all about speed and being able to react instantly. What about something a bit more everyday?
Well, think about personalized recommendations on streaming platforms or e-commerce sites.
Okay.
Spark streaming can analyze your viewing or browsing history in real time,
Yeah.
generating tailored suggestions for movies, shows, or products that you might be interested in.
So it's like having a personal shopper or entertainment concierge working behind the scenes, constantly analyzing your preferences and tailoring recommendations to your tastes.
Exactly. And the more data it processes, the better those recommendations become. It's
Yeah.
a continuous learning process.
No. It's amazing to think how this technology is working behind the scenes in so many aspects of our lives. But let's get back to those fault tolerance mechanisms for a second. You mentioned RDD lineage checkpointing and write-ahead logs. Are they all equally important? Or are there situations where one might be more crucial than the others?
That's a great question.
Yeah.
It's like asking which wrestling move is the most important.
Right.
It depends on the situation, right?
Yeah.
RDD lineage is your fundamental safety net. It's always there.
Okay.
It's like a wrestler's basic training, ensuring they can recover from minor setbacks. Checkpointing is more like a strategic backup plan for bigger challenges. It's like a wrestler taking time off to heal from an injury, but knowing they can return to the ring later. And write-ahead logs are like those contingency plans WWE has for live events, those backup angles they film, just in case something goes wrong with the main shot.
So depending on the specific application, the type of data being processed, and the level of risk involved, you might choose to emphasize one mechanism over the others.
Exactly. For some applications, RDD lineage might be sufficient for others, especially those dealing with critical data, or where even a small amount of data loss is unacceptable. You might need to implement checkpointing and write-ahead logs to ensure maximum protection.
So it's all about assessing the risk and choosing the right tools for the job. Just like a wrestler deciding which moves to use in a particular match.
Precisely. There's no one-size-fits-all approach. It's about understanding the strengths and limitations of each mechanism and tailoring your fault tolerance strategy to your specific needs.
Now, speaking of understanding the strengths and limitations, are there any drawbacks to this whole micro-batch architecture? Does it have any weaknesses that we should be aware of?
Well, just like even the strongest wrestler has a weakness. The microbatch approach isn't perfect. It's great for achieving high throughput and reasonable latency.
Yeah.
But it's not truly real-time in the strictest sense.
Okay.
There's always going to be that small delay introduced by the batching process.
So if I'm understanding correctly, there's always going to be a slight lag between when the data arrives and when it's actually processed.
Right. And while that lag is usually minimal, measured in seconds, it might not be suitable for applications that demand absolutely instantaneous processing, like high-frequency trading or certain types of sensor data analysis.
That makes sense. It's like the time it takes for a wrestler to react to their opponent's move, even a split-second delay can sometimes make a difference.
Exactly. And that's why it's important to choose the right technology for the right task. Microbatch processing is a powerful tool, but it's not a magic bullet. There are always trade-offs to consider.
So it's all about finding the right balance between speed, efficiency, and the level of real-time responsiveness you need.
Yes.
It's like a wrestler choosing the right combination of power, agility, and strategy to win the match.
Precisely understanding those trade-offs is key to designing and implementing successful Spark streaming applications.
Well said. I think our listeners are getting a real sense of the power and flexibility of Spark streaming and the key considerations when choosing this approach for their data processing needs. What I'm really curious about is if someone is just getting started with Spark streaming, what are some of the key concepts they should really focus on mastering?
Right.
What would you say are the essential building blocks for success in this world?
That's a great question. It's like asking a rookie wrestler,
Yeah.
what they need to focus on to become a champion.
Right.
First and foremost, they need to understand the fundamentals of distributed computing.
Okay.
Spark streaming at its core
Yeah.
is about processing data across a cluster of machines.
Uh-huh.
So grasping concepts like data partitioning,
Mhm.
task distribution, and how data flows through the system is absolutely essential.
So it's not just about writing code.
No,
It's about understanding how that code is executed in a distributed environment.
precisely.
Okay.
Then there's the whole concept of data serialization.
Mhm.
When you're working with a cluster, data needs to be efficiently moved around between different nodes.
Right.
Understanding how data is serialized and deserialized is key to optimizing performance and preventing bottlenecks.
That makes sense. It's like making sure the wrestlers are properly equipped and trained for their matches.
Yeah.
Ensuring they can move quickly and efficiently in the ring.
Exactly.
Cool.
And of course, you can't forget about fault tolerance.
Yeah, we talked about this earlier, but it's worth emphasizing again.
It is.
When you're dealing with real-time data streams, you need to be prepared for things to go wrong.
Right.
Mastering those fault tolerance mechanisms, like RDD lineage checkpointing and write-ahead logs, is crucial for building reliable and resilient applications.
Yeah, absolutely.
So it's about having a solid game plan, knowing how to recover from setbacks, and always being prepared for the unexpected, just like a seasoned wrestler.
Exactly. And finally, I'd say it's important to embrace the iterative nature of Spark streaming development. Don't be afraid to experiment, to try different approaches, and to learn from your mistakes.
Yeah.
Just like a wrestler refining their moves in the training ring, you'll need to iterate and fine-tune your applications to achieve optimal performance and reliability.
So it's all about continuous learning, adapting to new challenges, and always striving to improve, just like those dedicated athletes in the WWE.
Precisely.
Okay.
Spark streaming is a powerful and versatile tool, but it takes time and dedication to truly master it.
Right.
But the rewards are well worth the effort.
Well said. I think you've given our listener a fantastic roadmap for their Spark streaming journey, highlighting the essential skills and mindsets needed to succeed in this exciting field. It's been an absolutely illuminating deep dive, and I can't thank you enough for sharing your expertise and insights with us today.
It's been my pleasure. I always enjoy demystifying these complex concepts and helping people unlock the power of real-time data processing.
And a huge thank you to you, our listener, for joining us on this thrilling exploration of Spark streaming architecture. We hope you've gained valuable knowledge and maybe even a newfound appreciation for the artistry and strategy of professional wrestling.
Yes.
We'll be back soon with another fascinating deep dive, so stay tuned.